Hello everyone. I wrapped up the previous video by briefly mentioning what is the third exception for n-order execution. It is something which is called as functions. Functions are nothing but mini programs that perform specific tasks within your program. We'll be going through problem number 7 in order to understand the concept of functions. Let me first introduce you to the term variable. So far we've been using boxes which have some data value inside them and which also have names associated with them. The name associated with each of those boxes is called as variable in the world of programming. We'll be learning all about the concept of variable during next week lectures. Let me give you an overview about this problem and then I'll give you time to go through it on your own. Unlike the previous problems, you'll notice that there are two sections of code. One is called as the main code and the other one is called as the move code. Move code in the world of programming can be thought of to be a function. Couple of things that I want to share before you get started with this problem. The robot here is the arrow symbol. And the second thing which I want to mention is, you might be wondering whether you should be going through the steps in main code first or move code first. Every programming language will have a set of rules to follow as to where you need to start executing a particular program. And I can tell you that you should be going through main code algorithm first. Go ahead and pause the lecture video here and go through the problem 7 here. Let's start with step 1. Step 1 says put 2 in the moves box. So I'm going to go ahead and do that. Step 2 here says perform the steps under move code. So that's our cue here. We need to now switch to going through the steps inside the move code section. Let's go through step A inside move code. If moves is 0, which is not the case, stop performing and then do something else. So we don't really have to worry about the rest of the direction in this particular step because moves is not 0. So let's move on to step B. What does step B say? Move the robot forward 1 square in the direction that the arrow is pointing. So let's go ahead and move the robot forward 1 square. And then step C says decrease the value in moves by 1. Let's decrement moves by 1. So you'll end up with 1. Then step D says go back to step A. So moves is not 0. So let's go ahead and move the robot one more step here. And then what is going to happen is that your moves will now become 0. And now when you go back to step A says that if moves is 0, stop performing these steps in move code and go back to where you last were in the main code. So the key thing here is that for you to remember exactly where you left off when you started executing your move code. So this particular concept of going back is something which is called as return in the world of programming. So I'm just introducing you to all of these terminologies. We'll be going through each of those in detail when we cover that particular control flow concept. So now that we have gone back or returned to after step 2, so you're done executing step 2 in main code. So you'll now move on to step 3, which says rotate the robot 90 degrees to the right. Before I actually do step 3 on the grid here, I just want to mention one thing. You can always expect that you'll have 4 or 5 functions that you're running and you need to keep track of these green arrows which indicate the point in your code where your previous function call would go back to or return to. So you always need to have this mental model where you have one of these red arrows which represent the in order execution and one of these green arrows which represent the exception for in order execution. And you'll have multiple such green arrows depending on how many functions your program currently is executing. So let's go back to running step 3 of this main code. Step 3 says rotate the robot 90 degrees. So I'm going to go ahead and rotate the robot to 90 degrees. And then step 4 says put 3 in moves box. So after you put 3 in moves box, you're going to proceed with step 5, which says call the move code again. So I'm sure you can follow the drill. So since we started with moves variable value as 3, you'll be moving the robot 3 steps. So you'll end up with heart as the symbol that goes into the result box here. So sending all of you guys a little bit of love. Alright, so let's go through some of the questions here. What exactly does the function here enable you to achieve? Can you think of a way to not have this function yet be able to write this program? Pause the lecture video here and think about how you can have a single set of instructions to go through this particular program. If you were thinking that you can replace step 2 and step 5 with the set of steps inside the move code, then you had the correct answer to my question. Of course, you can always take a function and take all of its steps and put those steps as such inside your program that you're trying to write. Why not do that? Let me give you a couple of reasons for that. One is that when you want to type code over and over again, it's a waste of your time. The main objective of learning how to program is for you to save your precious time. So I definitely wouldn't be encouraging you to type the same code over and over again. That's something which all of us are going to learn to avoid as the semester proceeds. Reason number 2 is that programmers always make mistakes. Bugs are part of how you create programs. You'll soon learn why that is the case. When you have 2 different versions of the same code in your program, if you have a bug, you'll have to go fix both of those versions. Imagine having 10 different copies, then you'll have to go fix the bug in 10 different places. Not so pleasant, right? So that's the main motivation to have functions, so that you can have this capability where you can keep calling the function and getting some action done. So I use the term calling, correct? So calling is the technical term for what we did in step number 2 and step number 5 here. So I am, by saying that perform the steps under move code, I am calling or invoking the function. Okay, let's talk about a couple of other terminology with respect to function here. So we use the moves box to send input from the main code to the move code, correct? So there are 2 terminologies involved here. When you're sending details to a certain function, the function definition itself will have something which is called as the parameter. So function definitions have parameters, and parameters are just like special boxes, so special variables. The value that you're passing inside the parameter, which is a special box in the function, is called as the argument. So the actual data that goes into the parameter box is called as argument. So arguments and parameters are totally different terms. A lot of people mix both of those up, but I'm just like introducing you to both of those terms now. We'll again learn more about these terms as we go through the topic of functions. Alright, let's think about one more thing here. How would you change your code if you did not want the code to ever let the robot touch the lightning bolt here? Think about the answer to that question. I went through a set of exceptions for the in-order execution. Think about which particular exception here will enable you to achieve that purpose. Pause the lecture video here and think about that question. So if you were thinking we should add a conditional, then you had the correct answer. You sort of have to add a conditional saying that, okay, if the robot meets the lightning bolt, if the next step is the lightning bolt, maybe like skip over it or do something else like that. Alright, I'll wrap up this video here. In the next video, we'll be learning about state.